Hi, this is Divya, Assistant Professor, Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about the structure, operation and characteristics of BJT, that is structure, operation and characteristics of the bipolar junction transistor. What we are going to see here is, we are going to understand the BJT structure, how the structure has been developed, and analyze the operation principles. We are going to analyze the operation principles of BJT, and we are going to identify the characteristics, what are the characteristics are there, and we are going to explore it in how the how the BJT is especially used for the biomedical applications. Okay, first what we are going to do is understand the BJT structure, and then we are going to analyze the operation principles, and we are going to identify the characteristics, and fourth one is we are going to explore the biomedical applications where the BJT specifically is used for. Okay. Here, why this topic is important? Why this BJT, that is bipolar junction transistor, is very important? What the specific application it is used for in the biomedical applications? The real world problems, why we are going to analyze this BJT is that what are the real world problems we have which in regard with the BJT, that is bipolar junction transistor, and how it is affected, how it gets affected to the patients, and then impact of not solving it, not solving the issues, what the real world problems has been occurred. Okay, we'll see one by one. The real world problems. What is the real world problem? Signal amplification challenges in medical devices. Okay, we are facing signal amplification challenges where we have different types of signals in the biomedical applications, biomedical area specifically, that is ECG, EMG, EEG and so on. Okay, these signals, how these signals has to be converted into a certain output, and then it has to be analyzed what kind of issue it is. So for this signal amplification challenges is very important in the medical devices. Okay, next is how it is affected. Patients requiring continuous monitoring. Okay, clinicals making critical decisions, medical device manufacturers. How does these these problems are getting affected is that the patients requiring continuous monitoring. Generally we can tell that many patients we need the continuous monitoring for their well-being. Then clinicals making critical decisions, where although we have an exact paper format output of the disease, or we have diagnosing something, right? The clinicians will have difficulty in analyzing exactly what the exact disease or what it has disease is to be identified. They will be, why? Because since we are having many types of issues nowadays, or a disease nowadays, the clinicals will be they'll face very difficulty in analyzing what type of decisions we have to take, what kind of issue is that, and how the decision has to be taken care of. These confusions might be occur with the clinicians. And medical device manufacturers. Medical device manufacturers will face difficulties like see, we have different signal amplifications, as I told you, that is ECG, EMG and EEG. By using all these, and we have different and other signals also, we have to identify the heart rate monitoring and blood pressure, glucose level and all those stuffs regularly to the patients. Okay, these things can be identified by using or developing a small devices. Okay, to make these small devices very accurate, which is specifically for the specifically to be designed for the biomedical applications, is that though this manufacturer should have a very good knowledge about the device what they are going to develop. This is getting affected over here. Okay, impact of not solving inaccurate biomedical measurements. Okay, they would have identified a certain part. In that we have identified a certain part. In that we need a very accurate result in it. So the inaccurate biomedical measurements will not be solved. Delaying disease diagnosis. As I told you, the clinicals will have critical in decision making. Why? Because since we have many types of diseases nowadays, the identification of a specific disease can be delayed during a improper measurement. Okay, and reduces device's reliability and safety. By having these many things, the device will not be having a proper, reliable and a safety measures in it. Okay, why we are going to have this specific topic, that is BJT, bipolar junction transistor, is that the real world problems to be identified, and who is getting affected by these problems we have to identify, and then how this is going to impact the people this is going to impacted by these things. This is to be identified. See, this common emitter amplifier is mentioned over here. Why? Because in BJT, that is bipolar junction transistor, we are going to specifically align with this common emitter amplifier. Okay, why? Because the exact output can be given only by this emitter configuration. We have different type of configurations in this. We'll see one by one in the next videos. Thank you.